Good afternoon, everybody. I'm Dr. Scott Gerard, and I would like to talk about AIoT and how AI is more than just generative AI. Don't get me wrong, generative AI is awesome technology. It is the most fluid at text generation that I've ever seen. It can answer questions that you can pose in a general fashion. It can summarize text, and it generalizes across a lot of different tasks better than anything else I've ever seen. Generative AI really is very cool. For those of you who haven't ever seen this, this is the Gartner Hype Curve. This is the 2024 edition of it that just came out. And basically it starts, the expectations ramp up with the innovation trigger. And then we finally hit this peak of inflated expectations, where expectations are way higher than are probably justified. And as you can see, generative AI is at the very top of that curve right now. The next phase is going to be the trough of disillusionment. I do predict within the next few years, generative AI is going to go into its own trough of disillusionment. I don't think it's going to be super deep. It's not going to die there. But as we find out more things about what generative AI can do and can't do, people are going to spend more time thinking about its problems and how to mitigate them and how to correct them. And that's when we'll hit the trough of disillusionment. But after that, it's going to come back up and finally hit this plateau of productivity. So it is really cool technology. And if you want to follow it, it's also being enhanced at a very rapid pace. And there's a lot of leaderboards out there, particularly for the large language models, LLMs. The one that I'm showing here is the Vectara hallucination leaderboard. And you can see that GPT-4 Turbo currently has the best hallucination rate at 2.5%. What that means is that basically, on average, every 40 responses that you get back will have some kind of a hallucination in it. Now, it's gotten a lot better, but 1 out of every 40 is still something that you need to be concerned with. There are some use cases where it won't matter a lot, but some use cases where it will matter a great deal. But keep an eye on some of these leaderboards and see which ones you like the best. Each leaderboard focuses on different experiments. They measure different things. And so if you're interested in that, find a leaderboard that is similar to what you're trying to measure. But there are some problems with generative AI, and everybody knows that they hallucinate. But I think it's more than just that. This is a chart from Gartner, and it talks about how useful generative models are for various use cases. And if you look at the bottom, if you're doing content generation or conversational user interfaces, generative AI is really good at that. And you should definitely consider using some of those models if that's the kind of use case that you're working on. But if you're looking at segmentation or classification or maybe some recommendation systems, kind of a mixed bag. They can be helpful to a degree, but maybe not as much as certainly the content generation. And then finally, if you're trying to do predictions or forecasting or decision intelligence, they look like they do a pretty good job, but according to Gartner, they're not that good at that. And I'm going to show you some examples of that here. The Gartner chart is all about general use cases, but what we're interested in here is AIoT, artificial intelligence of things. So if you have some kind of a IoT device that has to have a user interface, not all of them do, of course, but if you do have one of those, then using generative AI as a conversational interface to your IoT device makes a lot of sense. The other one is this content generation. Not too many IoT devices need to generate marketing information, which is one of the classic use cases for generative AI. But you can use it to generate synthetic data so that you could generate some data to test out your IoT devices to see if that's working. I think that's a much narrower use case, but it's not. It's still very feasible and very workable. And so That's how I see generative AI primarily affecting the IoT community and the AIoT community. But the real message I'm trying to deliver here is use the right tool for the job. Hammers and screwdrivers and saws are not interchangeable. If you're trying to put a screw into a piece of wood, a hammer is not the right thing to use. And if you're trying to cut a board in half, don't use a hammer to do that. A generative AI hammer only works well on generative AI nails. Make sure you understand what your use case is and what the right solutions would be for that. There's a great many areas of AI that are not generative. Generative AI, at least in the current incantation with ChatGPT, is less than 2 years old. But AI itself is almost 70 years old. And there's many other areas within AI that, and there's been huge amounts of work in doing some of these. And this is by no means an exhaustive list. This is just some of kind of my favorites here. But search applications, that's kind of the bedrock of artificial intelligence. Most of the AI techniques that we do involve search in one form or another. And a lot of effort has been spent on figuring out the best ways to search. Logic. In the early decades of artificial intelligence, everybody believed this was the way to do artificial intelligence. And they went on for many decades where people thought that was the primary mechanism. Now, other things have taken over more recently, but the logic is still out there and still important. The next one is natural language processing. Large language models are buried kind of deeply down into this stack here, but there's a lot of other NLP techniques that people are using. If you're interested in probabilities, actually calculating correct probabilities with Bayesian statistics, it's a whole nother field of artificial intelligence. Planning. I want to take a trip to Hawaii. What do I have to do that? There's a whole section of AI for that as well. If you're interested in robotics, or if you're interested in perception, and by perception, I include not only the visual perception, but auditory perception, even including things like LiDAR and radar. There's a lot of different work that's been done in perception. Generative AI has some use in some of these cases, but there's a lot of other techniques that can be used as well. Multi-agent systems is one of my favorite. That's what I did my dissertation on. And in this case, we're not so much interested in the AI inside each of the agents. We are a little, but the primary focus is how do we get these different agents to work together? What's the social constructs between them? How do you get all of these agents working together to do the best job that they can? Of course, we're going to talk a little bit about AIoT. I think that's an up and coming field that's near and dear to my heart. And then machine learning is a whole field all of its own. So again, this is not an exhaustive list. Generative AI can help in some of these areas, but there's a lot of other AI techniques out there that can handle your use cases better in some cases. This is a particular example of a use case that I did. I worked for one of my clients. This is from a large electrical transformer. We measured 13 variables, continuously. This is a PCA analysis, so principal component analysis. The XY axis on the bottom of this represents the two largest dimensions out of those 13, and the two of them together explain about 46% of the variance of what we were looking at here. The Z-axis here is how many samples were in each of the various cells here. So 11 dimensions are kind of hidden what's going on here. The purple stuff, those are the places where anomalies were found in the data set. Okay, that's just kind of the background. So now think about this. If this is the data that you've been given, you're not going to build manual thresholds to figure out what's going on here. There's just too much going on. The shape itself is pretty complex. It's multidimensional. None of us can think in 13 dimensions anyway. So we have to do something. So machine learning anomaly detection is one really good way to handle this kind of thing. Furthermore, even if you were able to come up with some manual thresholds for triggering anomalies, the models change over time. If you get a new model of a piece of equipment, it might have a slightly different set of decision thresholds. If you've repaired a machine, it might change a little bit what's happening because it's not quite the machine it was before, or if they're aging. Machine learning is really good at doing this anomaly detection, and it's not really very good when generative AI isn't really very good at doing this kind of thing. This next example is the background here is the outline of the house where my own in-laws lived for a while until they had to leave. The red line here is a simulation of a person walking through this house. Now it's a little jagged. It's just a simulation. But what you can see is that pink cloud is tracking along with where the head of that arrow is. And what we're doing is we're looking at where are the probabilities of where people are going to be at. So the green circles are the sensor regions. The sensors are error prone. They sometimes fire when they shouldn't, and they sometimes don't fire when they should. The system is handling all that. I'm using Monte Carlo Markov chain to figure out how these people are moving through and where they are likely at. And the reason we're doing that is because we want to, figure out in real time what alerts we might need to send. And that would be sending alerts to the children of the elders, sending it to medical personnel or security personnel for some kind of a rapid response. We want to know as quickly as possible if something is wrong or not. Again, this is a great artificial intelligence, machine learning use case. Generative AI is not going to be good at figuring out these probabilities and tracking them through space and time. So the basic point I'm trying to get to here is use the right AI for the job. What job do you have? Find the right AI to fit that. Don't start with the AI and then try to apply it, right? AI is just so much broader than just generative AI. And when I talk to people, all they want to talk about is generative AI. It's cool, but there's a much bigger horizon out there to sample from. Generative AI can apply to some of the AIoT use cases, but not all of them. So you want to find the right AI for the job. And if you don't know how to do this yourself, find someone who knows the difference between AI and generative AI. They can help guide you down the right path, to pick the right sorts of algorithms to solve the job that you actually need to have be solved. I do this kind of work all the time. I've got a number of offerings if they would be interesting to you. This first one here is ask the right AI questions and get the right AI answers. This is really focusing on the conversations between executives and their data scientists. What do the executives need to ask the data scientists? And when the data scientists respond, what should the executives do with those kind of answers? How can they understand what's going on? They need to be involved in these things because there's a lot of business level implications for these AI models. The next one's a little step up. This is you have some ideas for AIs that you want to build. Let's have a workshop, figure out what those possibilities are, prioritize them, put together some kind of a roadmap. Maybe you just want to have ongoing access to an AI expert. Well, there's some fractional possibilities in there where you hire someone to come on, not full time, because most mid-level and small companies can't afford full-time AI experts, but you need someone to kind of help guide you and ask the right questions as you go. And then if you need to have some AI models implemented, that can also be done as well. So again, my point is, if you need some use cases solved, find someone who knows the breadth of what is possible and talk with them. Thank you for your time, and I hope you have a great rest of this session.